Hello, geometry students. Today we're going to be going over the Unit 4 review. I want you to go through first and see which of those questions you can do on your own. Hopefully you've gone over the whole packet in my previous video and you're able to do at least some of the problems on your own. I know some of the problems on this review in particular are kind of tricky, but we'll go over all that. But yeah, if you can, try to do as many as you can on your own, and then just come back to this video and go and take a look at how the other ones are done, the ones that you're not sure about. Okay. Well, with that being said, I'm going to go ahead and show my screen, and we're going to go ahead and look at the review. So for this first one, use the image and the area below to illustrate the Pythagorean theorem. So basically all I want you to do is I want you to say the area of the two smaller squares add up to the area, add up to, it's an A, add up to the area of the larger square, the area of the large square. So this is basically illustrating the Pythagorean theorem, because here you have a right triangle, ABC, and the area of this square plus the area of this square adds up to the area of this square. That's basically what we have there. So and that's true for all right triangles. If you take this side length, the two legs, and you square them, and you add them together, you get the length of the hypotenuse squared. Now, as far as for the definitions, like here it asks for define the Pythagorean theorem, define the converse of the Pythagorean theorem. For most of the definitions, I'll just have you go back into the packet and find where those definitions are. So for problems 2 and 3, you can find those on page 2. So go to page 2 and find this definition. Same here. Go to page 2 and find this definition, put it there. Okay? So don't just write page 2. Go to that page in the workbook, find the definition, and write the definitions in here. Okay. For number 4, it says if the square of the length of the longest side is greater than the sum of the squares of the lengths of the other two sides, the triangle is. So what it's saying for number 4 is, it's that a squared plus b squared is less than c squared. So if the square of the length of the longest side is greater than the sum of the squares of the sum, plus, of the squares of the other two sides, then this, if this, you have a triangle in this situation, then what you'd have is an obtuse triangle. Obtuse. Similarly, here, this is saying that the square of the length of the longest side is less than. So this one's basically saying the a squared plus b squared is greater than the c squared. In this case, this is acute. So this will make an acute triangle. So if we have the three sides of a triangle, we can always tell if it's obtuse or acute, or if it's a right triangle. If the a squared plus b squared equals the c squared, then that would be a right triangle. Okay, so if the a squared plus b squared is less than c squared, that's obtuse. If the a squared plus b squared is greater than c squared, then that's acute. And if the a squared plus b squared equals c squared, that's a right triangle. So here in this example, we have a right triangle here. So we have two lengths of this right triangle, And it's asking us to find the hypotenuse. So they're asking us to find this missing side length here, BC. Now, how do we find a missing side length on a right triangle? Well, hopefully you remember that's the Pythagorean theorem. A squared plus B squared equals C squared. So anytime you're looking for one missing side length on a right triangle, you would use this formula. A squared plus B squared equals C squared. So if you have a right triangle and you're missing one side length, you can use this. In this case, the A and the B, those are the leg lengths. So the A and the B are the two lengths that they give you here. And the hypotenuse is always the C. So the longest side is always C. That's the hypotenuse. And it's always opposite from the 90. In other words, the 90 kind of points to the hypotenuse. That's one way to think of it. So the other two sides are called the legs. So we're going to, and these are always your A and B. The legs are your A and B. So in this case, we have 15 squared plus 8 squared equals, and we don't know the length of the hypotenuse. Okay, so that's going to be 15 squared plus 8 squared. So that gives us 289 equals x squared. Now to get rid of the squared, what you do is you square root both sides. Hopefully you remember that. Square root that. That gives you that this length, the hypotenuse, is 17. Okay. I want you to go ahead and try this one on your own. It's basically the same problem. It's just with different numbers. Here, you're going to use the Pythagorean theorem once again because it's a right triangle and you're missing one of the side lengths. And once again, you're trying to find the hypotenuse on this problem. So it's set up just like how you did in the last one. So give that a try. Number 8, it says you are building a doghouse and need a supporting block of wood for the roof. So that's this length here that you're trying to find. Okay. Your boss went on an errand and took your measuring tape. Using the Pythagorean theorem, determine the length needed. If necessary, express your answer in the simplest radical form. So in this case, we have, again, a right triangle. You see the right triangle here? And we are trying to find one of the missing side lengths. So we're missing a side length on a right triangle. That tells us we're going to use the Pythagorean theorem again. Except in this case, they give you the hypotenuse, right? See how the hypotenuse is 26? They give you that length. The hypotenuse is always your C, so they give you that the hypotenuse, the C, is 26. Okay. Now we need to find x, so that's going to be one of the legs. It doesn't matter which one you consider it. I'll just put it for A. The other leg length goes here. So this would be x squared plus 22 squared is 484. Equals 26 squared, which is 676. To help us solve for x, we're going to subtract 484 both sides of the equation. So that'll give you x squared equals, and you're going to go ahead and subtract that, 192. Now to get rid of the squared, you could use square root. Square root. So that gives you x by itself equals the square root of 192. Now if you do the square root of 192 on your calculator, you don't get a nice number, right? You get, in this case, it's 13.8564 and blah, blah, blah. But we can simplify the square root. So that's what it asks. Express your answer in its simplest radical form. So when you have a radical, sometimes you can simplify it. So the way you want to do that is you'd want to make a factor tree. So we're looking for two things that multiply to give me 192. One thing I could do is 8 times 24. So these two numbers multiply to give me 192. And I can simplify I could break down the 8 further. So this would be 4 times 2. The 24 I can call 4 times 6. I can break down the 4 some more. This 4 breaks down to 2 times 2. The 2 doesn't break down, so I'm going to encircle it. So if it doesn't break down, we call it a prime number. So these are prime numbers. These 2's are prime, so they don't break down anymore. I'm going to go ahead and circle them. The 4 breaks down to 2 times 2 once again. The 6 breaks down to 2 times 3. 3 is prime as well. So the square root of 192 equals the square root of, and look at how many 2's we have. 1, 2, 3, 4, 5, 6 2's. 1, 2, 3, 4, 5, 6, and a 3. Now, when you're simplifying a square root, you look for doubles. So any doubles, yeah, there's double 2 here, a double 2 here, and a double 2 here. So any doubles that you see, those come out. So you're going to have outside the square root a 2 times 2 times 2. That gives you 8. Inside the square root is anything left that did not have a double. So in this case, square root of 3. So these come out as singles. That's one of the keys. So this comes out as a single 2, another single 2, and another single 2. And those 2 times 2 times 2 gives you 8. So that's where that 8 comes from. And what's left inside is square root of 3. This is just the simplified radical version of that. You could always test to make sure. You could always put the square root of 192, which again was 13.856, whatever. And you should be able to put this in the calculator, 8 square root of 3, and get the same answer. 8 square root of 3. And indeed, I do get the same answer. So that's how you could always check to make sure that it's the correct simplification. Okay. If this doesn't equal that, then you know you did something wrong. Okay. A triangle has side lengths 16, 30, and 34. Is the triangle a right triangle? So remember, if the a squared plus b squared, if it's greater than c squared, then this would be acute. Remember we talked about that? If the a squared plus b squared is less than c squared, then it's obtuse. In other words, the c squared is longer. The c squared is more than these two added together. And if it's equal, then it's a right triangle. So if it's equal, then it's a right triangle. So we want to see, do these 3 side lengths make an acute, an obtuse, or a right triangle? So we're going to check. We're going to do, and the C is always the longest side. Okay, that's key. So that's going to be 16 squared plus 30 squared. And I'm going to put equals, but we don't really know if it's equal. So I'm going to put a question mark here because I don't know if it's actually equal. And then 34 squared. Okay, so 16 squared, that's 256, I believe. Yep. 256 plus 30 squared, that's 900, equals 34 squared, which is, and again, I should probably put a question mark here because I don't know if it's equal, 1156. So do these two add to that? And they do. So that means that this side does equal. So this is equal here. So that means that this is a right triangle. So is this triangle a right triangle? Yes, it is. Okay. With that in mind, why don't you go ahead and try number 10 on your own? It's the same type of question, just with different numbers. You're going to tell me whether it's acute, obtuse, or a right triangle. For number 11 and 12, for number 11, you're going to go to page 9. Both of these are going to go on page 9. So for both of these, you'll find the answer on page 9. Okay, so go to page 9 and put those definitions in there. Find the length of the hypotenuse here. So in this case, what kind of triangle do we have? Well, we have a right triangle, right? But more than that, you see how these put little like swooshes with tick marks on them? That means they're trying to tell you that these two angles are congruent. So if these two are congruent, that means they're each 45 degrees because the angles inside any triangle add up to 180. So if you have one of them that's 90 and then two others that are congruent, these must be 45 degrees each so that the total is 180. Okay, they gave you that this is 90 already. So then you'd need 90 more, and it's split amongst these two evenly. So that means it's a 45, 45, 90. So remember when you looked at this one about 45, 45, 90s, you should be able to figure out what x is in this case. So the one way to think about it is you can think of this as a ratio. X over 9 equals, now hopefully you remember the other 45, 45, 90, and you could find that on page 9. Remember it's 1, 1, square root of 2. So the x over 9 from this triangle corresponds with the square root of 2 over 1 from this triangle. From here you can cross multiply. 1 times x is x equals, and then 9 times square root of 2 is 9 square root of 2. Okay, so that's the value of x here. For this one's another 45, 45, 90. You got a 90-degree triangle, a 90-degree angle here, and two 45s. So that means that, and you're using this example to make the proportion. So we have x over 13. But in this one's case, it's a little bit different because here the 13, that's the hypotenuse. So when I set up looking at this other 45, 45, 90, I want to make sure that I'm matching the hypotenuse here with the hypotenuse here. So the 13 corresponds with the square root of 2 from this one, the x with 1. Cross multiply. So that gives me that 13. So 13 times 1, that's 13, equals x times square root of 2. Okay. Then to get x by itself, we divide both sides by square root of 2. So that cancels here. That gives me that, I'm going to write over here, x equals 13 over square root of 2. Now, if you recall, I don't like square roots in the denominator. So if you see a square root in the denominator, you're going to want to multiply by that square root on top and on bottom. What that does is rationalize your fraction. So now on bottom, square root of 2 times square root of 2 is 2. And on top, we have 13 square root of 2. Okay. You can't simplify in this case, but if this 13 was divisible by 2, then you should simplify if you can. But in this case, it doesn't. So that's it. Number 15. It says in a high school baseball diamond is a square. So we have a square here. Now, what do we know about squares? That means that each angle here is a right angle, because in a square, each of the 4 angles in a square are each 90. They're each right angles. The distance from first base to second base is 80. So here's first base, here's second base. So that distance is 80. But since it's a square, that means all of these sides are 80, right? Each of these sides are 80 feet because it's a square, right? In a square, all the sides are the same length. So nearest foot, how far does a man on second base need to throw the ball to get it to home plate? So that's this distance here, D. So essentially I want to know this length here, but you might notice that what's formed over here, and I'm looking on the right here, is a triangle, specifically a right triangle. With each of the legs equaling 80. So, and notice this dotted line here, it cuts cuts this right angle in half. So that makes it cuts it into two 45s there. So that means each of these is 45 degrees. In other words, it's a 45, 45, 90. So from here, you're just going to treat it like the other 45, 45, 90s. So D over 80. And in this case, the D, that's the hypotenuse of this 45, 45, 90 triangle. So since it's the hypotenuse, it corresponds with the square root of 2 using this 45, 45, 90 template triangle. So the D corresponds with square root of 2. And the 80, the two legs, correspond with 1. Here you can cross multiply. D times 1 is D equals 80 times square root of 2 is 80 square root of 2. And that gives you the distance from second base to home plate. If you want it in terms of a decimal, you would just put it in your calculator, 80 times the square root of 2, and that'll give you 113.1, roughly. Okay. Now, the other special right triangle is the 30, 60, 90 triangle. So I'm going to go ahead and draw the template here, but you could also find the template triangle for 30, 60, 90 on page 9 of your workbook. So this would be 1, 2, square root of 3. So it's important to look at opposites here, right? So in this case, the 2 is the hypotenuse. It's opposite from the 90. The square root of 3 is opposite from the 60. And the 1 is opposite from the 30. Okay. For a detailed lesson of how this works, you can go back to where I talk about it in the lesson for the workbook. But in this case, I have D and 4 that I'm working with. So the D over 4, like that. Now notice D, this side length, is opposite from the 30. So these are opposites. This length here, the D, with 30. So what's opposite from the 30 here? Well, that's the 1. So D corresponds with 1 from our template triangle. What about the 4? Well, the 4 is opposite from the 60. And what's opposite from the 60 here? Well, the square root of 3. So the 4 corresponds with square root of 3. From here, cross multiply. D times square root of 3 is D square root of 3. Equals 4 times 1 is 4. From here, to get D by itself, we divide by square root of 3. Divide by square root of 3. So we've got D, I guess I'll write over here, I'm running out of space. D equals 4 over square root of 3. Now, again, I don't like square roots in the denominator, so I'm going to multiply by that square root on top and on bottom in order to get my in order to rationalize this. So square root of 3 times square root of 3, that's just 3. And on top, we have 4 square root of 3. Okay. Me personally, I don't care about rationalizing, but you're going to see it on the test, so I need to make sure that I at least show you how to do it. Okay. But again, whatever you got here, when you get D by itself, 4 divided by square root of 3, if you plug it in the calculator, you should get the same thing as if you put this in the calculator. So that's one way you can check your answer as well. 4 times square root of 3 divided by 3 should give you 4 over square root of 3. Same answer. These are all equal. Okay. Now let's take a look at number 17. The equilateral triangle to the right, well, I don't know why it says to the right, it's below it, has a height of 20 millimeters. Okay, so this height here is 20 millimeters. That's what they're talking about. I show you right there. So this 20 actually applies to this, not to this, not to the diagonal one, just to this one. What is the length of the side round to its nearest tenth of a millimeter? So this time they want it as a decimal, round to the nearest tenth. Okay, so we're looking for this side length S. But what I want to point out is that I can make it split into two triangles here. And we're going to look at this triangle specifically on the right. Okay, with the 90-degree angle here, this is 20 here, and we're trying to find what this length is, S here. That's supposed to be an S. Instead of S, I'm just going to use X, but just know I'm talking about that same side length. I don't like S's because my S's always end up looking like my 5s. But just know I'm talking about this S here when I put that there. Okay, so since it's an equilateral triangle, right, because they tell you it's an equilateral triangle, and we also know that in any triangle, the 3 angles should add up to 180. But an equilateral triangle, all the angles are the same. So what should each of these angles be? Well, they need to add up to 180, and also I need them to all be congruent. So what would be their measure? Well, they would each be 60, right? See how they add up to 180, and they're all congruent. So that's true in an equilateral triangle. All the angles are the same in an equilateral triangle. Now, this dotted line cuts this top angle in half. So this makes this at 30 here, because it's cut in half. But this one still is intact. That's a 60. So now what I have is a 30, 60, 90, just like here. So I'm going to create a proportion like we did in this one. So x over 20. I hope you see how I got that this is a 30, 60, 90. By the way, you're going to get one on the test just like this. In fact, everything on the review will be on the test. Mostly they just change the numbers, okay? So x over 20. Now the x is the hypotenuse. See how it's opposite from the 90? So what's opposite from the 90 in my standard 30, 60, 90? Well, 2. So x corresponds with 2. The 20 on this one is opposite from the 60. So what's opposite from the 60 here? Well, that's the square root of 3. So the 20 from this triangle corresponds with the square root of 3 from our template triangle. From here, we would cross multiply. So x times the square root of 3 is x square root of 3. And 20 times 2 is 40. To get x by itself, we divide both sides by square root of 3. Divide by square root of 3. Here, we could rationalize by multiplying by square root of 3 on top and on bottom. So that'll give me on top 40 square root of 3 over square root of 3 times square root of 3 is just 3. So it gets rid of the square root. Now it says they want it to the nearest tenth of a millimeter. So they want it as a decimal, round to the first decimal place. So I'm going to do 40 square root of 3 divided by 3. That gives me roughly 23.1. I got 23.09, but that 0.9 rounds up to 0.1. So that gives you the length of S here. Okay, so I'm going to put S equals, and this is in millimeters, so millimeters. Next page. Define sine of angle A, cosine angle A, tangent angle A. So hopefully you remember, and I've shown you this on the when we go over the packet. So, ka, toa, SOHCAHTOA. This tells you that sine, so sine of an angle, sine of A in this case, equals opposite over hypotenuse. So sine is opposite over hypotenuse. So opposite leg, opposite over hypotenuse. Okay. What about cosine? What about cosine of A? Well, cosine is adjacent leg over hypotenuse. Adjacent over hypotenuse. Adjacent leg, right? Finally, tangent. Tangent is opposite over adjacent. So tangent of an angle is the opposite side divided by the adjacent leg. Okay. Tangent is the only one that doesn't use the hypotenuse. You see that? Tangent does not use the hypotenuse. Sine and cosine, they both have over the hypotenuse. So let's go ahead and use those concepts to find what are the sine, cosine, tangent for angle t. So in this case, we want to find sine of t. We want to find cosine of t. And we want to find tangent of t. So if I'm looking from angle t here, I want to find sine of that angle. So sine is opposite over hypotenuse. So if I'm looking from angle t, what's opposite from here? Would that be the 17, the 8, or the 15? So opposite from t should be the 8. See how it's on the opposite side of the triangle? So opposite for sine, opposite over hypotenuse. The hypotenuse is 17. For cosine, I want the adjacent leg over hypotenuse. So if I'm looking from angle t, what would be the adjacent leg? Well, that's the leg next to it. That's 15 over the hypotenuse. 15 over 17. Tangent of t is opposite over adjacent leg. So the opposite leg over the adjacent leg. So that would be 8 over 15 for tangent of t. All right. For question 22, we're going to be using one of these trig functions to help us find the measure of x here. So you notice the angle that they give us is up here. That's what they're trying to show us, is that angle 5 is this angle, or 5 degrees, that's this angle up here. So this measure of this angle is 5 degrees, and we're trying to find x. Now, if I'm looking from this angle, from this 5-degree angle, would x be the opposite? Would it be the adjacent leg, or would it be the hypotenuse? Well, hopefully you can see it's on the opposite side of the triangle. So this is, from this angle, this is going to be the opposite. Whereas the other leg, this is the other leg. So this is the adjacent leg. So which trig function involves opposite and adjacent? Well, that's tangent. Tangent involves opposite and adjacent. So that tells you the trig function you're going to use is tangent. And in this case, it's tangent. So it's going to be tangent. And you always put the angle in here. So in this case, tangent of 5 degrees, equals the opposite side over the adjacent leg. Now in your calculator, you want to do tangent of 5, but make sure your calculator is in degrees. If it's in radians, it won't come out right. So if you do tangent of 5, now I know it says round to the nearest tenth, that's the first decimal place, but I always go at least one decimal place more when I'm doing my work. So I'm going to put that tangent of 5, and when you put in your calculator, hopefully you get 0.087. And over here we have x over 250. Now, what would I do next to get x by itself? Well, whenever you want to cancel a fraction, you always multiply by the denominator. So in this case, we're going to multiply by 250, both sides. So over here, you get x by itself equals, and then you just multiply these together. So I've got 21.9 when I round to the nearest tenth. So I round to the first decimal place, I get 21.9. Okay, make sure you're able to put in the calculator and get that exact same answer. Make sure you can plug all that in. Okay, it's going to be important on the test. Now you could also use trigonometry to help you find a missing angle. measure. So for question 23, they're looking for the measure of angle x. So that's right here. Well, whenever you're finding a missing angle, you're going to be using one of the inverse trig functions. So either sine inverse or cosine inverse or tangent inverse. Well, which one do we use? Well, it depends on what they give us. So in this case, they give us this 15 and they give us this 20. Now the 15 here, is that opposite from this angle, or is it adjacent leg, or is it the hypotenuse? Well, hopefully you can see it's a leg, but it's also a leg right next to it, right? So that's the adjacent leg. So adjacent means like sharing a border. So you can see that this angle shares this, is next right up against this side. So that's the adjacent leg. So this is the adjacent. And what about the 20? Well, 20 is not opposite from here. It's actually the hypotenuse. See how it's opposite from the 90? It's also the longest side, which tells you that this is the hypotenuse. So which trig function involves adjacent and hypotenuse? Well, that would be cosine. So we would write cosine of x equals, and I'm going to leave a little bit of space here, but it's going to be adjacent over hypotenuse, which is 15 over 20. Remember, cosine is adjacent over hypotenuse. So this involves adjacent hypotenuse. It tells me I'm going to use cosine. Now to get x by itself, we're going to have to cancel cosine. So the way we do that is we use cosine inverse. So cosine inverse of cosine x. That means you're going to use cosine inverse on the other side as well. So the way I want you to kind of remember this is whenever you're finding a missing angle, you're going to be using one of these inverse trig functions. In this case, you're using inverse cosine to cancel out cosine. That leaves you with x over here on the left. On the right, we want to do cosine inverse of 15 over 20. So in order to get to cosine inverse on most calculators, including this one, you're going to have to press the second button. So the second button there. So you press the second. For me, it's second. Then I press cosine. And you should be able to see on your calculator, it gives you cosine inverse. Then I'll do 15 over 20. And that gives me that this angle to the nearest degree is 41 degrees. Okay. For 24 and 25, the angle of elevation and angle of depression, you should be able to find those in the workbook. For those two problems, you should be able to find them on page 21 and 22. So look for angle of elevation. It'll say the angle of elevation is, or the angle of depression is, on these two pages. So go ahead and see if you can find those in your workbook. For number 26, it says, what is a description? I guess I'll write that. This is on page 21, and this one's on page 22. What is the description of angle 2 as it relates to the situation below? So angle 2 is right here. Would that be an angle going up or an angle going down? Well, in this case, it's an angle going up. So that would be an angle of elevation. So if it's an angle going up, that's an angle of elevation. So we'd say angle 2 is an angle of elevation. From the line of sight So whose line of sight is this? This is the balloon's line of sight, from the line of sight of the balloon. To, so what is it going to? It's going to the bird above. Okay. Angle 3 would be an angle of depression. Angle 4 is an angle of elevation. Angle 1 is an angle of depression. Almost done. 2 more. 27. Suppose you stand 60 feet away from a barn house. Your angle of elevation to the top of the barn is 22 degrees. Your eye level is about 5 feet above the ground. How tall is the barn from the ground? So we want to find the height of the barn basically here. Okay. It's not a very good picture because this person is like bigger than this barn, but let's go ahead and work it out. So we want to find X first. Then whatever we find X, we're going to add an extra 5 feet because the man who's looking at the barn is already looking from a perspective of 5 feet tall. So we're going to add an extra 5 feet to X to find the height of the barn. But first, let's just find X. So here they give us this angle 22 degrees, and they want us to find X. Well, is X opposite from here? Is it the adjacent leg, or is it the hypotenuse? Well, this is the right angle here, so the hypotenuse is here. So this must be the opposite. So this is the opposite side. So this is opposite from the angle we're looking at. Whereas the 60 here is the adjacent leg. So this is the adjacent leg. Okay, so which trig function involves opposite and adjacent? Well, that's tangent. So we're going to be using tangent again. So tangent of 22, so you always put the angle in here, equals opposite over adjacent. This will tell us what X is, and then we'll have to add an extra 5 feet at the end. So the first thing I want to do is I want to put tangent 22. Again, make sure your calculator is in degrees. So this gives me 0.404 equals, and on this side we still have X over 60. Now, whenever you want to cancel a fraction, you always multiply by the denominator. So we're going to multiply by the denominator to cancel that. So times these two together, that gives me that X equals 24 point, and we want to round to the nearest tenth, so 0.2. Okay, now don't stop there. That doesn't tell us the height of the barn. We have to add an extra 5 feet. So the height of the barn is, we add 24.2 plus an extra 5 feet. So that's 29.2 feet. I guess this should be a capital H here. There we go. To land the plane on the runway, the pilot must descend using an angle of depression of 4 degrees. The plane is currently at a height of 3,208 feet above sea level. Okay, we can see that there. The height the plane is flying at is right here, 3,208. How many feet away is the airplane? So we want to find this distance, X. Now, one of the key things here is that this 4-degree angle, that also tells you the measure of this angle here. So this angle here is 4 degrees, and the right angle is right here. So we have a right triangle, and we're trying to find the length of the hypotenuse in this case. So if I'm looking, this is the hypotenuse. And if I'm looking from this angle, would this number, would it be opposite, adjacent, or adjacent leg? Well, it's opposite, right? It's on the opposite side of the triangle. So this is the opposite, and we're trying to find the hypotenuse. So which trig function involves opposite and hypotenuse? Hopefully you remember that that's sine. So we'll be using sine in this case. And we're going to put the angle in here. You always put the angle in where the trig function is. So sine of 4 degrees equals opposite over hypotenuse. So that's going to be 3,208 over the hypotenuse, X. So I'm going to do sine of 4 which gives me, since I'm working with very large numbers, I'm going to go a few extra decimal places, but 0.06976, we'll say, equals, and on this side, nothing's changed. So 3,208 over x. Now, if I want to cancel a fraction, what you always do is you multiply by the denominator. So in this case, we'll multiply both sides by x. So when x is in the denominator, just make sure you multiply by that x there. Okay, so we got x times 0.06976 equals 3,208. So I'm going to write it as 0.06976x equals 3,208. Now to get x by itself, you divide by 0.06976 to get x by itself, right? Divide on the other side by the same amount, 0.06976. Divide that, and that'll give you what x is. So in this case, it's going to be 3,208 divided by 0.0. Okay, so that gives me the length of x is 45,986 feet. Okay, and that's it. Okay, I hope you're able to get through the review there, and I hope it wasn't too much trouble. If you understood everything in the review and you followed along, then you should definitely not have too much trouble on the test coming up. Well, with that being said, I'll see you guys next time. Have a good one.